All right, this is a conceptual question 26.6. Okay, so we have two resistors, R1, R2, and they're connected in parallel. And R2 is going to be bigger. I'm going to write that on there. And R1 is going to be small. I'm just writing that on there just to remind us. Okay, and that's just a bunch of questions about it. The first one is that I1 is equal to I2. They said the currents are equal. Well, for A, that's got to be false. Okay, they're in parallel, so they're both going to have the same voltage. So they can't have the and if R2 has a greater resistance, then according to Ohm's law, remember I equals V over R. It's a terrible V, but you get the idea. Okay, so if R2 is greater resistance, then it must have a smaller current. I2 has to be less than I1. Okay. The next one, B, says I3 is equal to I4. Okay. Well, that part has to be true. Although I1 is going to be more than I2, which we will show here. Okay. Although this one is going to be more than this one. Added together, this has to be I1 plus I2. And this also has to be I1 plus I2 because any current that went through those resistors has to come out through those resistors. So I3 has to equal I4. C, is just saying that the current is greater in R1 than R2. That's just another way of saying that I1 is greater than I2. We already said that was true. It has a smaller resistance, so it's going to have greater current. D, the rate of electrical energy consumption is the same for both resistors. We can prove that a couple of different ways. I think the easiest way to prove it is by saying that we know the rate of electrical energy consumption is just going to be power. That's going to be voltage divided by current. And the current's going to be V over R, which means it's going to be V squared over R. Well, they're both going to have the same voltage. So this is going to be the same for both of them. But R2 is going to be bigger than R1. So we know they cannot have the same rate of energy consumption. So that's got to be false. For part E, we're looking at the rate of electrical consumption. Energy consumption is greater than R2 than in R1. Just like the last one, we're looking really at power. And power, remember, is going to be V squared over R. Okay. Well, R2 has a greater resistance than R1. So it's not possible for it to have a greater power consumption than R1, so that's got to be false. For F, they're talking about the voltage difference between the 2 points. And the points they're looking at in this case are points C and D. And they said that the difference between those is equal to the difference between E and F. And that it's equal to the difference between A and B. Okay. And that is absolutely true, that those voltage differences have to be the same. I mean, C, D, and E and F are obvious because they're in parallel, but A and B are where those voltage differences come from. There's been no change in electric potential, no resistances to make it change. So those have to be true. So that is true for F. Okay. And then it talks about, it says for G, it says point C is at a higher potential than D. And if we look at point C, it is on the left. We know that this is conventional current, so we're talking about positive charge. And positive is going to move from high potential to low. And since the current is moving from left to right, C has to be greater than D. So we know that G has to be true. And for H, they say point F is at a higher potential than point E. Well, point F is to the right, and point E is to the left. Well, that has to be false. The only way because again, conventional current is going to go from high to low potential. Okay. Then they talk about point C and point E. So the point C and point E. Okay. And again, those are actually going to be that. Although those are on different lines, they're going to actually have the same electric potential because it hasn't even crossed there. So that's going to be false also.